So now today we will start the trust project, and before we start the trust project, we will have an example for trusses as a revision for what you have done before in structure in engineering mechanics. Okay, so we have a simple truss. As you can see, we have like a horizontal member at the bottom, horizontal member at the top, and some diagonal members and some vertical members. Okay, so I will start solving this problem with you, and I will share another screen. Can you see the paint screen now? So on this screen we have I will draw the truss here. Okay, so this is our truss, and we have here two supports. Hinge support at A, and we have here B, roller support at B, and we have the connection between all the member are bends. As you see in the example, all the joints are bend joints. Okay, the distance we have here, all the member are 2 meters long, so 2 meters, 2 meters, and also this height is 2 meters. Okay, the load we have in this truss, two loads. One of the loads is applied here at the middle, 10 kilonewton meter, 10 kilonewton, sorry. The distance between the load and support A is 3 meters. Another force we have at B, force, horizontal force 30 kilonewton. So in this example, we have two forces, vertical force and horizontal force. Okay. The requirement for this example is to calculate the reactions for this truss. Is number one. And number two, find the forces in members, in all members of truss. So we have two requirements. One is the reactions and one is the forces inside each member. So to do this, I will call all the joint first. So if this A and B, so we have this, let's say C, D, E, F. Okay, so we need to find the force in member AD, member AC, member CD, member CF, CE, sorry, member CF, and member EF, and member EB. Okay, so this is the two requirement we have. So now we can start. Does anyone have idea? Does anyone have idea what is the reaction we have in this example? Do you have any idea about the reaction we have? I'm waiting for your answers. Are you still with me? For the recording, I will try to make a post on the forum of the course, so you can see it after the class, maybe tomorrow or tonight. And thanks, Suvarna. We have 3 reactions. The reaction we have are 2 reaction at A, which is YA, and XA. So there's 2 reaction here. And because A is hinge, and we have here YB, because roller. As you know that we have 2 types or 3 types of supports as a revision. We have hinge support, roller support, and fixed support. What is the reaction we have for hinge support? 2 reactions, 1 vertical reaction and 1 horizontal reaction, X and Y. What is the reaction we have in roller support? Only 1 reaction in Y direction. For fixed support, we have 3 reactions, X and Y forces and moment M. Okay, so now we have 3 reactions in this truss. Okay, before I solve the truss, I have 1 comment on the loading we have, because as you remember from last year, the truss member is a member like this, and this truss member can only carry forces in the longitudinal direction of the truss member. Okay, so if this is longitudinal direction, so the forces can be tension force like this, tension force, or compression force like this. And if both tension and compression forces are called axial forces. Axial forces because it is applied or in the direction of the member. Okay, the truss, no moment on a truss member. The truss member cannot carry any moment. Do you remember that, or do you know that? So no moment transferred through the truss member because all the truss member are been jointed. So because it's been jointed, it cannot transfer moment. So for the member CF, the force 10 kilonewton, if it's applied like this, if we have this member CF and you have force 10 kilonewton here, this force is this force in the axial or the axis direction of the member. If 10 is 10 force in axial direction or perpendicular direction. It is not in the axial direction or the longitudinal direction of the member. So this force will cause moment on the member. And we cannot allow truss member to have any moment. So what we have to do? What we have to do is we need to change the location of the 10 kilonewton force. This is one of the tricks of this example. Okay. And in other direction, we can say that all loads should be applied at joints in trusses. Okay, so for truss, all the loads should be applied at the joint. So the 10 kilonewton force cannot be like that. Okay, so I will save this one. So now to proceed in this one, I will draw the truss again here. We have our truss here. Okay, and we have the supports. Hinge and roller support, and we have A, B, C, D, E, F, and the distance are 2 meter, 2 meter, 2 meter, and the distance is 2 meter. Okay, we have one load here at B, no problem with this one. Okay, we have 30 kilonewton here, but at the load was here 10 kilonewton. We will move this load and move it to the joint. Anyone has idea how to move this load to the joint and which joint better to transfer to, C or F? Anyone has suggestion for this one? Okay, so because it was in the middle or in the center line of the member, so it's better to keep the symmetry of the truss, put half to the near joint to the left and half of the force to the near joint to the right. So this truss, after some modification, become like that. We have 5 kilonewton downward at C, 5 kilonewton downward at F. Okay, this is just a trick before starting solving this truss. And again, you said we have 3 reaction. Here we have XA, YA, and here we have YB. So for the reaction, how can we find the reaction? We have 3 equilibrium equation. Summation forces in X direction should be 0. Summation forces in Y direction should be 0. Summation moment at any point should be 0 as well. Okay, so if we apply the first equation, summation X forces equal to 0. What forces in X direction? We have 2 forces in X direction. XA positive because it is go to the right. So we have XA plus 30 go to the right should be 0. From this equation, we can have that XA will be equal negative 30 kilonewton. Okay, what we mean by negative? What does this negative means? Do you have idea? Yeah, negative means the direction, so it is opposite direction because we assume it to the right, and then from the equation it is negative. This means that XA should be to the left, not to the right. Okay, and if you want to modify here, so what we will do is changing the arrow direction here and put the value. So the value here This is XA, and it is 30 kilonewton. Okay, so now we to go to the second equation. If we apply second equation, YA here, what forces we have in Y? We have, sorry, now we apply, if we apply summation Y equal to 0 equation, we have YA going up, so positive, YB also going up, positive, minus 5 because it's going down, should go up, okay, and then we have minus 5 again going down, should be 0. From this equation, can we find anything? Can we find YA or YB? This equation, from this equation, we can't get YA or YB because it is one equation and we have one equation and you have two unknowns. So this equation cannot be used to get YA or YB, but we will know that YA plus YB will equal to 10. Okay. So now we go to the last equation we have, summation moment at any point equal to 0. So which point to take the moment about or around? A or B or C or F? A. Can take the moment at A or at B. Okay, I will take it at A. Okay, here. The best thing is to take the moment at the joint where we have reaction to cancel the reaction, because YA passing through A, so doesn't have moment. 30 kilonewton also pass through A, doesn't have moment. What else doesn't have moment about A? This 30 kilonewton also because it passes through A. So the forces that make moment at A or around A is 5 kilonewton, 5 kilonewton, and YB. Okay. So if we apply this equation here, we have YB by the distance. What is the distance from A to YB? This distance is 6 meters. So YB by 6. Do you know what is the sign for this one? If is YB rotating clockwise or anti-clockwise? If we are here, so YB rotating in this direction. Okay, so it is anti-clockwise. Anti-clockwise, we assumed last week as positive. For 5 kilonewton, 5 kilonewton is rotating in this direction, so it is clockwise. So 5 kilonewton multiplied by the distance is 4. So I give it negative because it is clockwise. The other 5 also rotating in this direction, so it will be clockwise. 5 multiplied by 2, also negative because this 2 negative because it is clockwise, and this positive because it is anti-clockwise. Okay, so this equation should be equal to 0. From this equation, what is the only unknown we have? The only unknown we have here is YB. So from this equation, we will find that YB equal to positive 5 kilonewton. Okay, what is the mean by positive? Again, positive is the direction. The direction up or down? Up, because positive is the upward direction of Y. Okay, so now from this equation, we know that YB is equal to 5 kilonewton. Okay, what else we need to do to find the reaction? We still have only YA. How we find YA? If we go back to Y equation, summation Y equal to 0 again, what we have YA plus YB should be 10. If we already know YB as 5 kilonewton. So we have YA will equal to 10 minus 5, which is 5 kilonewton. Positive means upward or downward? Upward. So now we know as well YA equal to 5 kilonewton. So we have XA equal to 30, YA equal to 5, YB equal to 5. Do you have any question with the reactions? Okay. So now we shift to the next requirement, which is the internal forces. I will ask you a question. Do you know what is the method we are using to get the forces inside the member of truss? Anyone knows this? I will give you two minutes to think about this. What is the method we are using to get the forces in trusses? No, no going. Remember the method of section or method of joint? Have you heard about these two methods before? Okay, anyway, I will go ahead now. So we have the truss. Okay, so now we have the truss and we know the reactions. We have here supports. The reactions here are, sorry, 30 kilonewton, 5 kilonewton, and 5 kilonewton. We have hinge or bends here. We have 5 kilonewton out downward, 5 kilonewton downward, and 30 kilonewton in this direction. Okay, now we finish the reaction and we need to find the member forces. How many members we have? If we call this A, B, and we have C, D, E, F. So we have member 1, CAD, member 2, member 3, member 4, member 5, member 6, member 7, member 8, member 9. 9 members to get the forces in. Okay, the two methods we have to find the member forces are two. First one is the method of section. So we need to make a cut and then study the stability of the truss. The second one is method of joint. So we will discuss each joint by joint. And we can do also a combination between the two methods. Okay, so I will start with method of section first. For method of section, we need to make a cut in the members so that the internal force will appear. So if I make a cut here, so what is the forces will appear here? We will have force will appear in member DE. Force will appear in member CE. Force will appear in member CF. Okay, these three forces will appear. Firstly, why assume the arrows like that? Again, we will have, if we have member, a link member or a truss member, we have two direction of the forces. If the forces is pulling the joint, like the arrows go out of the joint, this means that this member under tension, and the tension force is positive. So the positive means tension. The other direction is if the member under pushing, like that. So the arrow should be going into the joint, not out of the joint. So if the arrows go in the joint, this means that this member under compression forces. So we have tension forces and compression forces. And the compression also can be represented by negative. So what is the best way to assume the force inside the member? Positive or negative? Should be positive, because this will make it easier for us. So we assume it tension, and the tension is positive. That's why my assumption was in this direction. Okay, so the first thing in the middle section that we need to make a cut in some members. How many members we can cut in? Can we cut in 4, 5? The maximum number of member we can cut in is 3. So if you cut more than 3, you will not be able to find the forces in. Okay, because when you cut, how many unknowns you have? Maximum 3 unknowns. That's why we cannot cut more than 3. Like this cut, I will call this cut as 1, 1. Cut 1, 1. One else may think to cut here, the yellow cut. How many forces in, if we cut the yellow cut, how many members or how many forces we cut into? Member AD is number 1. Member CD is number 2. Member CE is number 3. And member CF is number 4. So this yellow cut is not accepted, because if you try to solve this cut, you will have 4 unknowns and you cannot get any forces from this cut. Okay, so the maximum number of member you can cut into is 3. Okay, so I will remove this yellow cut, and I will keep the purple cut. Okay, when you cut like that, okay, you need to study the stability of each part itself. Okay, so when we cut, we have this 2 member here, and vertical member, and we have horizontal member here, and you have the diagonal member here, and you have also a diagonal member somewhere here. Okay, this is our members. We have here the two reactions, 30 kilonewton, 5 kilonewton, and we have the force here, the force here, the force here. This force we will call it FDE. This force FCE. This force is FCF. And we have two joints here, joint C, joint D, and joint A. Okay. Anyone has idea how to get the forces in these members? Yeah, we will use the sine and cosine rules, but before this, how many unknowns we have, as we mentioned? 3. Is that correct? We have 3 unknowns. So we need to apply our 3 equilibrium equation. We will apply 3 equilibrium equation, which is summation x equal to 0, summation y equal to 0, and summation moment equal to 0. Okay, so to apply this equation, we need to get all the forces or all the loads are horizontal and vertical. So we have FD no problem, FCF no problem, but FCE is inclined or diagonal member. So we need to get the two component, vertical component and horizontal component of this one. Okay, if we go up a little bit in this triangle here, this green triangle, what we have in this triangle, I will take it out here. So we have this perpendicular angle. This will be our theta. This member is 2 meter and this member is 2 meter. Okay, if we have an angle and the opposite 2 and the adjacent 2, how much is the angle? 45 degrees. How can we find this angle if we don't know? Okay, if we don't know, if it is not 1, so we know that 10 minus 1 will be, theta will be equal to 10 minus 1, the opposite, divided by the adjacent, given to us that the angle is 45. Okay, so if we are here now, this will be our theta. So the vertical component will be FCE sine theta. The horizontal component will be FCE cosine theta. Okay. Do you have any question for that? So now we know that theta is 45 degrees. So the vertical component will be, I will replace this one with FCE divided by root 2, and here the horizontal component FCE divided by root 2, because sine 45 is 1 divided by root 2, cosine 45 is 1 by root 2. So now for this problem, we know all the forces now are horizontal and vertical, so we can start to get the loads or to get the forces. How can we start? And don't forget, we have here at C, we have 5 kilonewton at C. How can we start? Which one of the equilibrium equation can be used here? If we used summation x equal to 0, how many forces in x? Yes, if we use x, we have 30 kilonewton, FCE divided by root 2, and FDE and FCF. So we have 4 or 3 unknowns. But if we use summation y equal to 0, we have the reaction, the force FCE divided by root 2 going up, so positive, minus 5 going down, the load, plus 5 going up, the reaction. Any other forces in y direction? No? So this equation should be 0. So now 5 positive will cancel 5 negative, and then from this equation we will find that if CE is equal to 0. Is that correct? Okay, so the force in the diagonal member FCE is 0. So this will be 0. The vertical component will be 0 and the horizontal component will be 0. Okay. So now we proceed to the next step. Okay, I can't go more for this one. Okay, so we find the forces in the horizontal on the diagonal member as 0. Then what we can do? If we draw this again here, this part. Okay, 5 kilonewton, 30 kilonewton, 5 kilonewton go down. This distance is 2 meters. How much is the force we get here? Just remember this point D. The forces here is 0, which is if this point D. So if CE equal to 0, we still have force in member FCF and force in member FDE. Okay. If we apply same ideas again, how can we get the forces in member DE and CF? Now we only know that if CE, the diagonal, is a 0 force member, and now the next step is to find DE and CF. How can we find DE and CF? Can we use summation x equal to 0? No, because we still have 2 forces in x. So we have two unknowns. So the next step or the next equation, the final equation we have is summation moment at a point should be 0. Which point to take the moment at? If we take the moment at C, what will happen if we take the moment at C? The 5 kilonewton here passing through C, no moment. FCF passing through C, no moment. 30 kilonewton passing through C, no moment. So the only forces will have moment at C is FDE and this 5 kilonewton. Okay. So if we apply summation moment at C equal to 0, how can we find the moment? What is the moment of FDE? FDE is the force. To get the moment of it, we need the distance. What is the distance between C and member FDF? This is the distance, which is 2 meters. So FDE by multiplied by 2 meters. This force is rotating clockwise or anti-clockwise if we are at C? Clockwise. Is that right? So I will put negative because it is rotating clockwise. Okay. If we look at 5, this 5 kilonewton is also rotating clockwise. So 5 kilonewton. What is the distance between this 5 kilonewton and C? Also 2 meters. And I will give negative because it also rotate clockwise. So 5 by 2, this 2 should be 0. From this equation, what is the value of FDE? If we send this to this side, so FDE will be negative 5 kilonewton. What is meant by negative? What does this negative mean? Compression. The negative value mean compression. Because we assume it at the beginning as tension, so it is compression, actually compression, and the direction should be to the left, as Tian said. Okay, so this force is compression force. Okay, so the final force we have, so we get FDE and FCE, so the last one is FCF. If we apply summation x equal to 0, so we can now find FCF. How much is FCF? We have FCF positive because we assume it go to the right. And we have negative 30 because it go to the left. Plus or minus FDE. FDE is actually will go to the left, so negative 5. All this should give us 0 at the end. So finally, we will find that FCF will equal to positive 35 kilonewton. What is meant by positive here? The positive sign means tension. And this means that this force is going to right. Okay. Okay, do you have any problem with this section or this cut we have done? This is called is the method section. Do you have any question for the method section? For the method section, you need to make a cut or a section and then study the stability of the, the cut bar and then get the forces. Okay? Okay, so now we shift to the remaining members. To do the remaining members, we need to use the method of joint. So now I will do the truss again. for this member A, B, C, D, E, F. We have at C 5 kilonewton down, at F 5 kilonewton down, at B reaction 5 kilonewton up, at A 5 kilonewton up, and here 30 kilonewton, and here 30 kilonewton. Okay, at the end of the example, we need to put all the forces we have got on the member. So member CE, the force we got is 0 force member, so I put 0. Member DE, it is a negative or a compression member. So I put 5 kilonewton. What does this two arrow mean? If you see the arrow going into the joint, this means tension or compression? Compression. You can represent it in another way. You can put negative kilonewton instead of the arrow. Okay, about CF, what about CF? Member CF, we found that the forces in member CF is tension, and the value is 35 kilonewton. Another way to represent it is putting it as positive 35 kilonewton. Okay, so now we have found all the members in the cut, but we still have to find member AD, member CD, member EF, and member FB, and member EB. Do you have idea how to get these members? We will get the forces in this member using method of joint. Method of joint means that we will study the stability of each joint. Each joint, if this is a joint, each joint, because this joint cannot transfer the moment, so each joint can have only forces in X direction or Y direction. So the stability of this joint, or the equilibrium equation for this joint, is only 2 for joint. Summation X equal to 0, summation Y equal to 0. So for the method of joint, we can only apply 2 equilibrium equation at each joint, summation X and summation Y. Okay, let's see if we study the stability of joint A. If we take joint A out, so this will be joint A. When you take joint A, you need to, don't forget to take the forces at A, 30 kilonewton and 5 kilonewton up. What else will be at A? When we take the joint out, so we have cut in the members, member AC, so we have FAC, and also member AD, so we have FAD. Okay, so how many members in connected to joint A now? How many unknowns at A now? 4 or 2? We have 4 forces, but how many unknowns? How many unknowns in this one? 2, only 2. So the unknowns we have for this one is 2. FAD is number 1, FAC is number 2. Okay, so another important information you have to keep in mind, you can only solve or study a joint has 2 unknowns. Okay, this is an important notice, because like if you want to study joint D, before you know that this 5. How many members connected to joint D? If we ignore that we know the 5 kilonewton, how many forces or how many unknowns? 3. If you want to study this node or this joint at the beginning, you cannot do this joint because it has 3 unknowns. So you can only start studying joints with 2 unknowns. Okay. So now we return back to our joint A. How to deal with joint A? Joint A, we still have one inclined force. We cannot deal with inclined forces, so we need to get the 2 components of it, because all the angle here is 45 degree because all the members are 2 meters. So similar to what have we done before, this will be FAD divided by root 2, and this FAD divided by root 2. So now we have FAD divided by root 2 in x direction, FAD divided by root 2 in y direction. How can we find the forces? Can we start with summation x or summation y equation? How many unknown in x? If we study x direction, we will have 2 unknowns, FAC and FAD by root 2. So it's better to study summation y equal to 0 at the beginning. Summation y equal to 0, we have FAD divided by root 2 going up, so it is positive, plus 5 kilonewton going up, no other forces, so this should be 0. From this equation, we can find that FAD will be equal to negative 5 root 2 kilonewton. What is the negative means? Compression. So this means the force in this member will be compression member or compression force. Okay. So if we want to add this force to the truss, what is the direction? To the joint or out of the joint? The arrows should go to the joint. So 5 root 2, or in another way, negative 5 root 2. Okay. Do you have a problem with this? No. After we get FAD, now we can apply the other equation. Summation x equal to 0. What we have in x now? We have FAD, which is negative 5 root 2 divided by root 2 plus FAD minus 30 kilonewton. FAD going right, so positive. If 30 kilonewton going left, so negative. This 3 should be 0. From this equation, root 2 will cancel root 2. So we have negative 5, negative 30. So we have finally FAD equal to positive 35 kilonewton. What does this positive sign means? Tension or compression? Tension. So FAD will be tension force. Okay. If we want to add this to our truss, so we will put the arrows going out of the joint, so 35 kilonewton. Okay. Do you have any problem with this? Okay. So now we have finished joint A. Then to find member CD. How to find member CD? Do you know how to find member CD? We can find it from joint D or C. What is the better? What is the best? Joint C. Joint C is easier for this one because we have a zero force member, so it will be easy for us. But you can also get it from D, but it will be a little bit harder because you have inclined member and then you need to analyze. So it is better to go for joint C. But both are okay. For joint C, what is the forces of the member we have at C? We have 35, 5 go down, 0 member, and our member FCD. So at joint C, if this joint C, we have 35 kilonewton to the right, 35 kilonewton to the left. We have 5 kilonewton go down. We have a 0 member here, and our member is FCD going up. Okay, so we don't need to apply X direction because already X direction is stable, 35 left, 35 right, so 0. And if we apply summation y equal to 0, we have FCD going up, positive, minus 5 go down should be 0. So FCD will be positive 5 kilonewton. Positive means tension or compression? Tension. Okay. So if we add this to our truss, we have here tension force. So the arrows go out of the joint, 5 kilonewton. Okay. Okay, to the left, to the right. Now we finish all the member to the left, to the right. How can we find the member to the right? Can you do it yourself? I will give you 10 minutes to do it. I want to see from you member EF and FB and EB. Okay. Now it is 412. I will give you up to 425 to do it. Okay. And I will have a look on what you have done. Okay, guys, have you finished? Anyone want to show me what he has done? Guys, are you still here? Okay. Still trying, still doing it. You need more time. Okay, guys, you finished? Anybody can say what is the forces for member DF and FB, EF and FB and EB? Tian, Gung, Suvarna, G. Anybody has finished? The other guys, Zhang, Shan, Liu, Martin, Ding, Ronxing, Winky, Lonling. Nobody here? Okay, you are here. Have you tried? Okay, so Vanilla, you have EB is correct, FB is not correct, and EF is correct. So can you check the equation for FB? It should be 35, not 25. Maybe you have just to make the 5 kilonewton something wrong in the calculation. So you can check. And thank you for telling me the answer you got. Okay, no worries, Savannah. Okay, guys, thank you for participating in this small activity. And do you have any question for this class now? Yeah, FAB 7.07, but compression. No, compression. Gong is compression. I will just give you some tips for this one. If you have a look on this truss, is it symmetric or unsymmetric? If we remove the member EC because it is 0, it is symmetric or unsymmetric? It is symmetric truss. So the forces to the left should be equal to the forces to the right. So member EB should be similar to member AD. So if member AD is negative 5 root 2 or 5 root 2 compression, this means that member EB will be same. Member EF is similar to member CD, will be positive 5 kilonewton. And member FB will be similar to member AC, will be 35 kilonewton. Okay, so if we do the calculation, then we will find that this force is compression 5 root 2. And this force is tension 35 kilonewton. And this force is tension 5 kilonewton. Okay. All good? No question? Is the method of joint easy, or do you have problem with the method of joint? This is the two methods we can use for truss analysis: method of joint or method of section. Some trusses you can use method of joint to solve all the truss. Some trusses you need to do method of section in combination with method of joint. So it's up to you to use whatever of them, doesn't matter. But at the end, you need to find the forces as required. Okay. So now we finish this truss example, and then we go to the second part of our tutorial today. I will close this one. As we mentioned last week, we need to do some projects in groups. So today will be one of them, and we will have the truss project. I will share with you. Share now with you the truss. Can you see my screen now? Okay. This is a group project. Again, a truss project. We will do like some trusses. Okay, so I think you have this. You can find this one on the website, or I will send you by email. Okay, I will send it now to you, so everyone has it with him. Have it with him. Okay. Please let me know when you receive it. Have you received it? The project or the truss project description? Okay. Okay, please have a look on it while we are reading. I will read it with you. Okay, now this trust, the description give you some description of the bridge and trusses used in the bridge. And for us, the truss bridge is our first project this year or this semester. And this project you will work in group together. Each group should be from 3 to 4 members. Okay. And you all at same practical class, which is now online. Okay. Now I will divide you to group first, and then I can explain to you what is required from each group. Okay. Because I need to explain some stuff for you. And if you have a look at the end of the project description, You have many classes for your class. The online class will use truss 4. Okay. Can you see this one? Okay. Can you see the truss now? So the online class will use truss 4, which is this one. Maybe it is better to do it like this. Okay. Hopefully you see it now. Okay, so this is our truss. And as you can see, the truss is 30-meter span. Each small spacing or each small bay is 3 meters. So we have 10 bays. Each bay is 3 meters. The depth of the truss is 3 meters, and this truss is inverted truss. As you can see, the supports at A and K are in the bottom chord and at the top chord, and the bottom chord is overhanging from below. Okay, so this is our truss, and please don't use the other trusses, otherwise you will be the marks will not, maybe your project will not be marked. So it's better to follow what we are saying and use truss 4. Okay, and I give you more 10 minutes or 8 minutes to form the groups. Okay, so no problem. So can you form the groups, guys? We are 12 now or 11, excluding Savannah because he is not related to this class and me. So we have 11 members today. So at least we need 3 groups. So if you can form 3 groups for me and send me the names. Okay. I will give you up to 4:45 to send me the names, please, to continue on the explanation of the project and what you have to do. Okay, Ji Liang. And also another note, guys, this groups are not related to the groups in previous class. This is new group, so you don't have to stick with your group last week, but this group will continue for the whole project of the trust. So, and thank you, Liang, for the group. So you are with Ding and Juan and Zhang. Is that correct? And I will give you a name or ID, group D1. Okay, because you are the first group to send me names today, so you are group D1. Sorry. Okay, just remember the ID, group D1. We still need two groups. The other guys, are you ready to send me the names, please?
Sir, we can choose a group of 2 or 3. 3 people. Excuse me, sir. Excuse me, sir. Can you hear me?
Okay, Martin, Cheng, Kong, and Tian, and the other guys, are you ready to give me the names? Because we need to continue the class.
Yes, I mean we can choose the group of 3 people too.
Okay, so Jiang, Tian, and Ronxing, you will be group D2. Okay, Kong, you can form a group with yeah, it's better to have 3 at least guys, because you need to check some members, and at least 3 will be better for all. So if you can make it 3 members would be okay. So does anyone want to join the group with Ronxing and Jian Tian? No, this group is not for the end of the semester. Okay. For only project 1, yes. Each project we can form a new group. And it depends on the student attending this class, because I know the class maybe has more students, but only us attending today. So if you know more students are not attending today and you want to ask them to join you or they will join you, I don't mind. Okay, so up to launching Shuai and Jiang Tian, you are two members in this group. D2, okay, and then Gong and Zhang, are you a group now? Because I will give you group D3. So group D3 will be Gong and Dongling Zhang. Is that okay? D3. Then the fourth group, D4, Kong Liu, Gao Mingui, and Winky Hu. Okay, so now we have 4 groups up to now from D1 to D4. Do you know your group number now? Yes, Martin, you can be with Zhang in one group. Okay. So I will tell you the numbers of the group again. The first group is Liang Jie and Ding Minghao, Yuan Haobing, and Zhang Shu is D1. The second group D2 is Jiang Tian and Ronxing. This is group D2. Group D3 is Donling Zhang and Zhao Chongong. Okay, so this is group D2. Group D3 is Martin Li and Dongling Zhang. And the fourth group is Kong Liu, Gao Minghui, and Winky Hu are group D4. Okay, so now today we have from D1 to D4, and you know now each group number. So from group D1 to D4. Okay, so please keep this group with you or know your group. And now we return back to the screen. Can you see the truss now? Are you seeing my truss? Okay. I will explain to you what we are going to do in this truss. I will copy this truss here. Okay. Can you see the painting screen now? Okay. If you have a look on the truss description, it's giving to you that we have 2 types of loads on this truss, as you can see. Just as you can see, we have 2 forces, G. Can you see this G? Where is G applied? If you can see my truss, G is applied at joints from B to J. And again, as you can see, the forces are applied at the joints. Because as we mentioned before, the truss all the loads should be applied at the joint. Here, as the traffic move in this direction, car or whatever, this is the traffic. So the cars or the traffic will pass through this line. That's why the forces are applied to the top chord. Okay. We have two forces, G and B. G is representing the dead load of the truss or the on weight of the truss. And it is giving to you that G is 60 kilonewtons. So 60 is G value. Each one of them is 60. Not the summation of them 60. So it is giving to you that each one of them is 60 kilonewtons. Okay. What else will be applied to the truss? The traffic load, which is B, or the life load, because this is a bridge, so it is a traffic load, car, trucks, buses, whatever, and it is giving to you that this life load is 210 kilonewtons. But what you expect? You expect that B is everywhere or B is moving. G is dead load, so G is always there on the truss and it will be at each node from B to J. Because it is a dead load, so it is always applied on truss. But because B is a life load, so it is sometimes there or not there. So it is sometimes existing, or we can say it is not there all the time. Okay, so if we have a look here, so we have B moving, and it doesn't, the question doesn't give you where is B. Okay, but only given B is 210. What we will do is each group will be assigned a position of B. So if we say B is here, B equal to 210 kilonewtons. So B will be at point B for group D1. So group D1 will solve this truss with G60 and B 210 at B. So at this joint for group D1, what is the load here? 60 plus 210 equal to 270 kilonewtons. Okay, so what you have to do is analysis the truss, get the reaction, and then find the forces in the members as we have done in the example for this case. This for group D1. Group D2, what will do group D2? Group D2, the B is not here. The B or the life load will be at joint C. So joint C is assigned for group D2. And the value of B is 210. So what is the total load at C for group D2? It will be also 270, but not at B, will be at C. Okay, and so on. So we have group D3. Group D3, the load B will be at joint D. So we will have B here, no B here, and we have B here, 210. So the maximum value or the total load will be 270, but at joint D. Okay, then the last group we have for this class is D4. So D4, the load is applied at joint E, and B here is also 210 kilonewton. So the maximum load still 270. Okay, so each group will analyze the truss with the value or the load B applied as at a point. So group D1 at B, group D2 at C, group D3 at D, group D4 at E. Okay? But don't forget that the forces G is existing for all of you at all the nodes. Okay? Or all the joints, sorry. Okay? Do you have question for this? For that? All clear? Do you have any question? Yeah, each group will, you are not only doing the joint, I will tell you, but you are solving one load case. Each one of them is a load case. Because it will be too hard for you to solve the truss several times to get the all the cases. But each load case you have G G plus B at one point, like group again D1 at joint B, group D2 at joint C, group D3 at joint D, group D4 at joint E. Okay, so what you will do, I will explain more for you. What you will do as group, let's say group D1. So group D1, this will be our truss. Okay. Okay, so this is group D2, D1, sorry. For D1, you have to let's say this is a truss group, this A and this B, C, D, E, F, and so on. Okay, so what you have to do as group 1, you have here B Z plus G equal to 270 kilonewton. Then only for this one G 60, 60, 60, 60. Okay, so what you have to do as group D1, you have to firstly find the reaction here, X, A, Y, A, and here YK. Okay, so find the reaction. Then use method of section or method of joint to find the forces in member, this member, this member, this member, whatever. So each one of you will do some members. Okay, this is the first requirement we ask you to do for this week. If I will return back to the project description. Can you see it? Can you see the group description now? Okay, if you see the description, please let me know, because sometimes the sharing is not working. Okay, now you see the project description. Okay, if you are seeing the group description now, you can see that the dead load will be 60 kilonewton and the live load will be 210. Okay, and what we need to do is to do one combination load case, which we have done like G plus B, and then next step we will do using the software, but let's keep in this one today. So each member of the group need to at least get the force in 4 members or 3 members. I will check here. Okay, if you can see this one here. So this is the first step is hand calculation for the forces in the members. So you need to each student find the forces in 3 different truss members. Okay, so if you are 4 student and members, you will have at least 12 members by hand calculation. Okay, so if we return back to the explanation I am doing here. So let's say I am first member of the group. So I will select this member 1, let's say 2, 3. Okay, my mate in the group, my colleague in the group will use this as member 4, 5, 6. The next member will do like 7, 8, 9. Okay, so you can choose any other member number 4, use this 10, 11, 12. Okay, so what you have to do is each group will do the root case, and each student in the group will select 3 members to get the forces in. Okay, all clear? Do you have any question for this one? Do you have questions? Each group know which load case they should try or should work on? Yes, Gong. In the next weeks, we will during the next weeks we will ask you to use the space gas software. Okay, but you need first to finish the hand calculation and then go to the software. We will do use the software just to check our calculation with the software, and all the models are ready on the website. You can have a look on the website, the Learn Online website, and you can see your truss. If you have like used the software before, you can have some trials. If no, so you can wait until we ask you to do it. Okay, Shan, you can join group D4 because we are 3 members, so you can join D4. Okay. Do you have any other question, guys? We are this project is continuing for maybe up to week 6, so we are going through it. Okay, I will revise the session and then get the name out and send you exactly each group members and the name and what is the root case for each group. How could we contact each other? You can contact them by email, or if you can have Zoom sessions. Okay. You cannot contact each other now. Don't have any way to contact. You don't have any way to contact Gong. Okay. Any other question you have? Okay, guys. Thank you for attending today. Okay, thank you. I will stop recording now.